Hi, I'm Anuraj, and I'm going to be talking about the Internet computer. So, what is the Internet computer? The Internet computer is a decentralized computing network. It is a public blockchain that hosts smart contracts that can run at web speed, can serve the web from cyberspace, run efficiently, and can scale within an environment that has unbounded capacity. It has the capacity to extend the internet to be the world's compute platform. The infinite blockchain gives the possibility of extending the capacity for smart contracts and data, and thus can run almost all computers. So, what this would mean is that all personal computers and computers used for business and other operations can basically be run on the Internet computer itself. It is being developed by the Definity Foundation. So, to understand why the internet computer would be useful, we have to look at the current problems that are being faced within the tech industry. First up, we have the requirement of big tech. So, most systems and services are currently run from private infrastructure. Complexity from having to use proprietary legacy stack. So, services like cloud, CDNs, databases, web servers, application servers, frameworks like Kubernetes, all of these could be involved in getting an application up and running. Insecure applications. Firewalls are required at several stages, and at any single stage, let's say if one doesn't work, or if it is misconfigured or some bad code is present, then it could basically make the entire operation insecure. Extremely high spending. Since so many parties are involved in so many services, a lot of spending is required and it has to be done for the entire duration of the operation. Control of data. Data goes into the hands of these companies and they can basically use it in any way that they wish to. Users might not be sure that they are interacting with smart contracts. Most dApps are made from a comb of smart contracts and insecure websites that are running in the cloud, and so users can never be sure that they are interacting with the smart contracts themselves. So the Internet computer aims to provide a complete alternative to the traditional IT stack. Everything can be built upon it, and it has similar speed, capacity, and usability. So, how does it work? The Internet computer is created by the Internet Computer Protocol. It forms the world's first web speed, web serving, public blockchain network, which can grow its capacity with demand. It is self governing through the NNS. It combines special node machines run in huge numbers by independent parties from independent data centers around the world. Thus, it is a blockchain computer which is unstoppable and the code is tamper proof. Even more impressive is that its performance rivals that of the cloud. So basically, it combines networking capacity as well as computing capability into one. So, to understand how it works, we'll have to look at how the system is built, that is, the hierarchy of the network. It is composed of four major things: canisters, subnets, nodes, and data centers. At the base are the data centers, which could be in the thousands and are present all across the world. They host standardized node hardware. These nodes are several number and they are combined to create a huge number of subnets. These subnets host canisters, which are the compute units and which are uploaded by users, and they number in the billions. Now, the ICP has an open onboard governance system, which is called the Network Nervous System or the NNS, which is used for controlling, configuring, and managing the network. So, the NNS is responsible for managing data centers. Data centers apply to the NNS to get into the system. While the NNS itself is about open governance, it permits participation into the network. The NNS has also a lot of other functions. For example, monitoring the node machines looking for statistical deviation that could indicate underperformance or faulty behavior. It also plays a huge role in token economics. So, what is token economics? So, the NNS generates new ICP tokens to reward nodes that are being run by data centers and neurons that are voting within the NNS, which is how it decides on proposals that are submitted to it. These nodes are being run by miners. Here, miner is a bit different from the traditional concept of cryptocurrency miners. Now, this action is inflationary since new tokens are being generated. Data center owners and neuron owners can then exchange their tokens with canister owners and managers. Canister owners and managers convert these tokens into cycles and use those cycles to charge up their canisters. When those canisters perform computations or store memory, they use cycles and eventually they have to be recharged with more cycles to continue running. And this action is again deflationary. So now we come to subnet. Now, what is a subnet? Subnet is an integral part of the system. So a subnet is used for hosting a distinct subset of the software canisters hosted by the Internet Computer Network. A subnet is created by bringing together node machines drawn from different data centers in a manner controlled by the NNS. They collaborate via the ICP in order to symmetrically replicate the data and computations pertaining to the software canisters that they host. Now, subnets are tamper proof and unstoppable. So, the NNS combines nodes from independent data centers while constructing subnets, which ensures this tamper proof and unstoppable nature. The subnets are transparent to users and software. So, what this means is that users and canister software only need to know the identity of a canister to call the function that it shares. So, in contrast to conventional machines, the canister identity and function correspond to the IP address and the port respectively in case of the conventional one. Now, the NNS can split and merge subnets in order to balance load across the overall network, which is also transparent to the hosted canisters, and so there is no interruption. Now, there are different types of subsets with different properties, and when code is being written, it basically has to be mentioned as to what type of it is when while uploading data. Basically, the different types are data, System, fiduciary, and NNS. So the NNS is something that cannot be accessed. And basically, all of these subsets have different properties and capabilities. Now we come to another integral part of the system, a canister. What is a canister? Canisters are basically special smart contracts that run within dedicated hypervisors and interact with each other via a publicly specified API. It consists of WebAssembly bytecode created by a high level language like Rust or Motoko that can run on a WebAssembly virtual machine and the images of the memory that it runs within. The interesting thing is that WebAssembly bytecode is already in most major web browsers, and thus it basically makes the entire system easy to adopt. So, functions shared by canisters can be invoked in two ways: update call or query call. For an update call, any changes that it makes to data in the canister's memory are persisted, whereas for a query call, any changes that it makes to memory are discarded after its run. The canis changes made by update calls are tamper-proof because the ICP blockchain computer protocols run them on every node in the subnet and allows currency. And it takes around 2 seconds. And for query calls, they're inexpensive and complete in just a few milliseconds. This is because they don't run on all the nodes in the subnet, but then it means they also provide a lower level of security. Now, canisters have also the property that they can create new canisters. Now, see, from here we can see that basically it is really easy to create applications on it. Any high-level language that could compile to WebAssembly bytecode format could be used to develop applications on the internet computer. Currently, the internet computer already shows impressive performance. Now let's come to the advantages of the internet computer. First of all, it can host any number of canister smart contracts efficiently. That is, the code and data of any number of smart contracts can dealt by it. We can run them concurrently. So, which is basically adapts to scale. So therefore, what it means is it can process any amount of computation and thus it is highly scalable and can account for a wide variety and range of applications. Now, canisters are unstoppable and tamper-proof, and firewalls aren't required. So this is because it is the entire system is provided by end-to-end blockchain security. Canisters can serve web content directly to end users. Users can interact with blockchain services directly without holding tokens. Now, complexity of stack is reduced. So, no web servers, application servers, or CDNs or database servers are required. So, canisters conserve user experiences directly into web browsers, and so web servers aren't required. Native edge architecture is present, which requires no content distribution networks to speed up services. No DNS service is required since the internet computer is a giant DNS server, and no firewalls since blockchain security is present. It works at web speed and is powerful, so it is not that far away from mass adoption. Combats platform risk, so no API is being revoked, since dependency on platforms is reduced for the applications that are being built on the internet computer, since it is completely independent. Data sharing can be managed by transparent, open, tokenized governance systems. So, what are its uses? It can be used for tokenized internet services, for pan industry platforms, decentralized finance and smart contracts, enterprise systems, and websites. It already shows quite good performance and it has a lot of potential applications in the future. Thank you.